Good afternoon, everyone. As you are aware, this is the Q&A session for the third lecture. Today, we're going to have the Q&A session about Dr. Ahmed Radwan's presentation about scripting, EIUs, and neuroimaging formats. First, I will like to thank you, Dr. Radwan, because he woke up very early to be today here with us. Dr. Ahmed Radwan is an Egyptian radiologist, and I would dare to say that a neuroradiologist. He obtained his medical degree from the Misr University of Science and Technology in Giza, in Egypt, and afterwards he trained in radiology in Cairo at the Ain Shams University. And since 2016, he's been living in Belgium, where he did pre-doctoral training in biomedical sciences and in neuroimaging. And between 2018 and 2023, he worked on his doctoral dissertation. His dissertation was about the use of resting state fMRI and constrained spherical deconvolution fiber tractography for presurgical mapping, especially in patients with brain tumors. Amongst his achievements during his PhD, he built an automated workflow to build patient-specific fiber tractography maps that can be used in clinical applications. Also, he showed that the constrained spherical deconvolution technique or making the fiber tractography with this technique outperforms the classical DTI to identify some tracts, for example, the corticospinal and the arcuate fasciculus. And finally, he showed that resting state fMRI is as good as task-based fMRI to accurately map certain brain functions, which could improve patient tolerability of these mapping procedures. Thank you once again, Dr. Radwan, for being here with us.
Thank you, Kaiser, for the kind introduction.
Okay, the idea of these sessions is that we start asking the questions, so please feel free to start. Somebody wants to.
Who's going to be the first one?
Well, Ahmed, thank you very much for your cooperation. This is amazing. And I'm a pediatric neurologist and I'm based right now in Colombia. And I wanted to ask you, because we have seen a lot of patients, well, a lot of not, but some patients who doesn't have an hemisphere have had a stroke, a perinatal stroke. And we don't have any studies to our knowledge that assess the DMN or the resting state of those patients who have this type of prenatal lesions. I mean, so my question is, are these ROI always present despite the structural lesion?
That's a good question, Sebastian. It's nice to meet you. I would be actually kind of curious about that. I have worked on some data from cerebral palsy patients. I guess this is the clinical terminology for the condition you're describing, the perinatal arterial ischemic strokes. Indeed, in some situations, these lesions tend to be quite extensive, maybe even affecting an entire hemisphere. I don't know if you have ever collected resting state data of such patients or not.
No, we have not.
I would encourage you to give that a shot. These resting state networks are indeed preserved in many cases, even with profound structural lesions. It was one of my earliest projects with my colleague, who is now also a postdoc, Dr. Jeroen Blommert from the KU Leuven, where we looked at the cerebral palsy data, resting state fMRI, and we constructed these tailored parcellations for the cortex using the resting state data, actually. So indeed, we do find these networks still being preserved to some degree in what remains of healthy tissue in the brain. Now, this is as far as functional data is concerned. When it comes to parcellation based on the structural information, it tends to be a bit more challenging, especially if you would like to use, for example, PreSurfer, which I love. For this problem, actually, we devised a solution that was published in 2021, which we called virtual brain grafting. And there, the idea is to remove the pathological tissue if you have a lesion mask for that pathology, for the ischemic stroke area. You can try and replace it with healthy-looking tissue, and then feed this filled image into PreSurfer, and that reduces the chances of hard and soft failures to quite a bit of like a decent extent. However, of course, it is not perfect. There are other solutions there where you could carry out like a tissue segmentation and then apply a parcellation from an atlas to that remaining healthy tissue. However, there I would highly advise that you do a label propagation as well. So it's not simply registration and then applying the labels to the pathological brain, but then you also rely on the probabilistic segmentation of the gray matter, cortex and subcortical gray matter to kind of achieve what is called the label propagation. So that's a transfer of the labels from the warped atlas or template image into the mask of the gray matter of your patient. And that tends to give a better outcome.
Great, that's amazing. Thank you.
Thank you for the question.
I think I would like to ask also one question, and it's something that I find even after years of working with neuroimaging, I'm still kind of it's hard to get my head around it, and it's the different orientations of your imaging. So, and I don't know if probably some of you might be aware, but there is not radiological orientation, and also the neuroimaging forward as itself can be transformed into, or like has some components that are called the QS, the Q form and the S form, which are sometimes confusing. And sometimes, for example, you open your brain, you open the MRI and it's flipped or it's upside down, and you read online and it's like you have to change the S form, the Q form, figure it out which one is what, and it's just a mess. So like, I'm gonna leave it like that. So I know this is kind of a very technical question. So I don't know if if you have if you could kind of, I don't know, walk us through a little bit the differences between S form, Q form, and obviously radiological versus neurological orientation in neuroimaging.
Thanks, Carolina. That's a very interesting question and quite technical. I agree. Nice to meet you, by the way. So as far as I understand it, S form and Q form are both transformations that describe the orientation of the image. You have, of course, the radiological versus neurological orientation first. This is something I don't think I mentioned in the lecture, but so radiological orientation is kind of how how would I describe this? I think it's more of a legacy thing where, as radiologists, we used to look at the patient from a specific angle. And from that angle, the right and left used to be flipped, right? And this kind of orientation has been carried on into the modern day. There's, of course, the neurological orientation where right is right and left is left. So if you look at an image in radiological orientation, the right side of your hand is actually the left side of the patient, right? This can be confusing for some. However, it is the most popular, I think, and wider used orientation out there. Unless you're in the SPM world, which uses mostly the neurological orientation. I do find this a bit confusing sometimes, but you get used to it quite quickly. Now, as far as the S form and Q forms are concerned, these are both transformation matrices that describe the orientations of the image. Typically, this kind of thing is generated for you correctly from a DICOM to NIFTY conversion, right? However, sometimes this can go wrong depending on the converter. And then also sometimes, I guess, the image header itself can influence the outcome there. The idea, if I am not mistaken, is that both the S and the Q form need to be exactly the same. Otherwise, there might be a problem in the orientation of the image. And depending on which software you're using, different packages prioritize different transforms, actually. So I think ANTS, I don't know if you're familiar with the advanced normalization tools. This software actually prioritizes the Q form. So it doesn't care at all about the S form. Whereas FSL works mostly with the S form. So it is very important to make sure that if you're using different combinations of these two packages, that both of your S and Q forms need to be exactly the same. Now, as far as the numbers inside these transformations are concerned, I cannot make sense of that. It's just beyond me. However, if I understand it correctly, these values, they describe the extent of the image and its orientation. You don't need to understand all the details therein. As far as I'm concerned, I mean, I've come this far. I still don't understand everything in the S and the Q form, but I'm happy to learn more about that. But it is something that I've had to deal with multiple times. If I ended up with very strange orientations in my image, that I look at these transformations myself and I figure out, one of them is wrong. They are not identical to each other. And then you can try and copy one to the other. There are different tools to do so, as you have described, for example, with if the orientation is incorrect, you can use different commands, right? So in FSL, there is FSL reorient to standard that kind of does a very simple rotation of the image in 90 degrees to make it similar to the orientation of the MNI. So it is not a registration tool. It only rotates and moves your image slightly. Well, not so slightly, but it doesn't really match the MNI at all. Right? It only matches in terms of where's the front, where's the back, where's the right, where's the left, what's up, what's down. Kind of thing. I believe also in FreeSurfer, there is one of the earliest steps that are applied in the recon all pipeline is concerned with reorienting the image to the RAS orientation of FreeSurfer. So there are also different orientation systems for different neuroimaging packages, but it's quite easy to get them to match if you do, for example, let's say you insert an image into recon all and you have your parcellation output, but you want to put it back to the original space. Then you have the MRI_convert command with the flag -RL. If I'm not mistaken, this stands for reslice light. And if you give it a template image, which is, for example, your native T1, in same orientation you had it in the Nifty before feeding it into FreeSurfer, then your output will be in exactly the same space as that one. There can be some cumulative errors if you do this multiple times in a row. So let's say you have your aparca seg, you first transform it to the native T1, and then from the native T1, you want to go to a diffusion space or an fMRI space. You always need to be careful there because sometimes there will be some minor errors that will sum up in the Q or S form. And some different software packages have different tolerances for these differences in the S and Q forms between your target and your input, for example. There's a cool command also in ANTS. If your S and Q forms have like minor differences, but really minor, and the orientation is exactly the same, and you can evaluate this visually, then you can actually use a command called copy image header information from ANTS. You feed it with an input, a target, and your source image, your moving image, and it will copy all of the header information from one to the other. So if your voxel size is the same, your orientation is the same, but there are only minor problems or minor differences in the Q and S forms, you can actually get over this quite easily. But of course, use with caution. You always need to be careful if you're editing the header of one image, because when you're taking away all of the information with which you can actually do a sanity check, and things can get quite crazy quickly. I hope that answers the question a bit.
Thank you very much.
Yes. And yeah, it was really good. And I agree. I mean, the QS, the numbers inside those matrices are just, they're beyond comprehension. But that answer, it's quite clear. And thank you very much for that.
So this reinforces the fact that an image without a header, just as any file without metadata, doesn't make sense. So exactly. It's always very important to when you're dealing with neuroimaging or any file that you can also have knowledge and can get to know the metadata about this imaging file, because otherwise, even when you translate it from system to system or from a reader or to transform this data, if you don't have the header, then you won't be able to make any kind of transformation, because actually all the information is there, and it's this information from the header that is taken to process the matrices of data that images are.
Indeed.
Atsuhiko, thank you, please.
It's a really nice thing about the Nifty 2 format, where the header is included in the same file. So it's very difficult for you to lose it unless you do something, pretty extreme to the Nifty 2 image. However, with the older formats, like Nifty 1 and the HDR IMG and the analyze format, sometimes indeed the header file would get lost. And then you have a big problem. MGZ, for example, the format that FreeSurfer uses also has all of the header information within it, and so does MIF, the format of MRTrix.
That's correct. And I would like to add to that you should always try to keep a copy of your original files. So always create or keep a copy of the original without touching. Literally, as it comes out of the scan, create a copy and use the copy, or to work on whatever you want to do, and just leave the original untouched without touching. And then, because if something goes wrong, if you lose the data, if you, for example, change all these, if you register the image or you translate it or you modify it or you do something and you want to go back, you will need to have, or you will want to have that original data. So always, always, always create a copy and work on the copy, or like there will be the same, the original and the copy, but create a copy and have the copy and do not touch it, the raw file. Yeah. And ideally in DICOM as well.
I see this is coming from experience. I've been there.
And Suiko, please.
Thank you. Can you hear me?
Yeah.
Can you hear me?
Yeah, we can hear you
Okay,
just
okay.
fine.
My name is Atsuhiko from Japan. I'm a neurosurgeon in Japan, and I have a research about the neuroimaging analysis for the post-operative epilepsy surgery and neurofunction complications. So I'm now dealing with the nifty data. So my understanding of nifty data is the voxel image with geometric information. And so my question is that whether the geometric and anatomical relationship is preserved or not during the process of scaling with FSL.
Of scaling? Do you mean?
Yeah, so for example, so scaling up and scaling down. Yeah. So
Okay.
during the process of normalization to standard brain with FSL.
Right. So typically when you're doing a nonlinear registration, whether in FSL, ANTS, SPM, or any other, you get a file output that is not strictly your image, but something called a warp. Right?
Oh, yes.
And the warp describes the mapping from one space to another per voxel. Right? So
Yes.
your registered image is not necessarily faithful to the patient's anatomical information. That is to say that the precentral gyrus will have moved, for example, to match that of the MNI template or the target that you're registering to. However, the warp file that you have will be describing how these voxels moved, whether a certain voxel was shrunk or expanded to match that of the template. Now, from that warp, you can calculate what is called the Jacobian determinant, and that you can use to calculate changes in volume, for example, when you're doing this warping, right? And with these two, you can actually infer information about volume loss or gain, which is something that is used in the context of voxel-based morphometry, VBM.
Yes. I'm
Provide loss or gain or changes in gray matter volume. But you can also use this kind of information to do what is called a deformation-based morphometry, which is not necessarily specific to one tissue or another, but looks at the whole image. It's a bit tricky if you're working with post-operative data, and I say this from experience because I worked a bit also with post-operative data as well as pre-operative. And there you can achieve, sometimes you can achieve a better outcome if you have a lesion mask that you subtract from a brain mask and you use this to constrain your transformation. So I don't know which software you're using exactly, if it's only FSL or have you...
yes, FSL and MATLAB. Yes.
Okay, so in FSL, you can feed it with this mask, which has the whole brain covered in ones, except for the pathological area. And that basically tells NERT, which is the nonlinear registration pipeline of FSL, to ignore the lesioned area and to only do the matching based on the healthy tissue. This typically gives you a better outcome. But of course, before you reach that stage, you need to run FLIRT. So I don't personally use FSL for registrations, even though it is very powerful. I dislike this idea of having to do FLIRT first and then FMIRT. it's in ants, it is super cool and quite convenient if you get used to their command line interface. It's a bit counterintuitive at first, but if you read the documentation thereof, you will make sense of it quite quickly. They also give you some nice wrappers, like the ants registration sin.sh script, which runs, it's a wrapper around the ants registration command itself. It's also funny to know that a large part of the software within ants is coming from this other tool called the Insight Toolkit, ITK. So in a sense, you know, if you make a script that wraps around ants registration sin is actually wrapping around ants registration, and that is also wrapping around ITK. It's a bit of a, you know, the Russian doll, the babushka, I think it's called, that you open and there's a smaller one inside and then another one inside and so on. It's yeah, just a way to look at it. One nice resource for this kind of thing, just to get oriented or to kind of crash into the registration tools, whether of ants, SPM, or FSL, is Andy's Brain Book. This is a website, so it's on the Read the Docs website, Andy's Brain Book. I can type it here in the chat.
And
Brain Book. Let me also get you the actual link.
thank you very much.
My pleasure. I mean, I've had this question myself multiple times, and I still go back to Andy's Brain Book and Brain Blog whenever I can, because it is really an amazing resource. It is Andrew Jahn is the author of this website, and previously there was only a blogspot. There you go. But now there's also this Read the Docs page, which is really very useful. He covers many different pieces of software, including ants, FSL, some MR tricks as well, and SPM. He also talks about ASL, like arterial spin labeling processing, resting state fMRI. There's also some AFNI, like information about AFNI, the software package in there, and also the viewer MRI Crow GL. But you'll see all of that for yourself. I'm not going to do any marketing for Andy, but I do really respect that guy. He has very nice work.
Thank you very much.
Yeah,
It's all
and I
open
think
source and free, yeah.
I'll second that recommendation, because Andy's Brain Book is, and he also has videos, so it's really good. So if you have problems or you just don't understand how to do something, just go and check his stuff, because it's really good.
Yeah, his videos are very nice. His name is Andrew Jahn. I forget which university he's from, but I remember he's from the States. And he's been making these videos for like more than 7 years. I remember watching Andy's Brain Blog when I was still in Cairo. So this was like 2016.
Robert, please.
Right. Hi. First of all, thank you for your nice talk or lecture, however you want to call it. I would have needed that before I started touching, advanced imaging analysis. And what I thought was very nice is that it was a very slow beginning, and we're just, keep going with everything. And so I also have like a very basic question, because you touched shells, right?
Yes.
Very quickly. And so when I downloaded FreeSurfer the first time, and I got everything installed, and then people just told me which kind of commands I had to use, and they just didn't work. And it took me 1 week to figure out that I was running in Bash, but the commands that they gave me were actually C shell commands. So the whole thing, it was a week of stress for nothing. So maybe for everyone who is, so I'm still very new to the whole thing. At least now I know Bash and C shell. But could you maybe quickly touch on that? Because I think that might be an important thing before we get going with FreeSurfer, or like any scripts that we're going to look at in the future. What is a shell? How do I recognize which shell I am? and I'm in, and or which one I should use. And if there are multiple options, because apparently for FreeSurfer, you can use C Shell and Bash, which one would you prefer? Like, is there one where you said everyone uses Bash usually, or like, you know?
That is a cool question, Robert. Thank you. So I'm not a computer scientist by background. My understanding of this kind of thing, at first I thought actually that Bash is a programming language, but then I quickly realized, hey, it's really kind of not. It's more of a scripting language. As far as I understand Shell, it is a kind of an interface. You can think about it in a similar fashion to the Windows Explorer. It is just working with commands, right? And the shell that I refer to is the Unix shell, which is what you find in Linux, but also in Mac, and now also in Windows as the PowerShell, right? Since I think Windows 10, the shell itself has different flavors, right? So there are different ways to communicate with this environment. Bash, which is short for the born again shell, if I remember correctly, is in my experience the most popular. Most most softwares that work in shell will be able to handle Bash without issue. You've referred to FreeSurfer. I also referred to FSL, Ants, MRTrix, and yeah, what else was there? Afni, I think, also works in Bash. There are many others out there that work in Bash. How you can find out is typically if you have a script, for example, there's a shebang line, what we call a shebang line, in the very top, which has an exclamation mark and then a hash sign, and then says bin bash, for example. From that, you can figure out whether this is bash or CCSH or CSH or the latest one, ZSH, which is included by default now in, I think, all new MacBooks and iMacs. You can easily switch between them by just typing the name of the shell you want in the terminal itself. So if you have ZSH, for example, you just type bash, then it shifts to bash. If you have bash and ZSH is installed, then you just type ZSH, and then you shift to that one. I hope that clarifies it a bit, but I relate to what you were describing earlier because I've had this confusion as well. And typically, if you're watching, for example, Andy's Brain Book, Andy will be mentioning which shell this is. Right? You can also see that the prompt in the very beginning, like if you open the terminal now and you ask, which, if I'm not mistaken, there was if you type a command that is wrong, right? A command that isn't even there, like if you just type shell into your terminal, you'll find that there's a command not found error being printed to the terminal. And that is preceded by a dash dash, right? But there are other ways you can find out exactly which shell terminal it is. I'm going to Google this now.
Yeah, I can add a little bit on that if you want.
Yes,
So,
please.
so actually, in the FreeSurfer lecture, Harry Marr, he's a programmer, he's a computer scientist. There are like 15 minutes. There's a 15-minute talk given by him on Bash and terminal and how to solve these things and the differences. So I would recommend just watch the FreeSurfer video that we send you, and then you have a little bit better idea of what it is. However, in a nutshell, my understanding is, so every computer has the way, as you know, medical doctor, this is how I understand it. So I was gonna be a little bit kind of simple, and it might sound a little bit stupid, but whatever. So the computer has kind of recipe book behind, like running on the background the whole time. So every time you ask your computer, or you click on something, start or close or whatever, the computer, it doesn't really know what's happening on your screen. But what it does is that it goes back to that recipe file. And it looks like, okay, if you click this button means do this. So that's what happens. The bash and the shell itself is the kind of structure, the language, to call it somehow, of this script. And it's usually it's also called the config file. in order to know, there are many different computers, depending on the operating system, will have different languages. For that's I shouldn't use that term because it's not a language, but whatever. It have different like languages for this shell. There's Bash, there's CSH, there's ZSH, there's what's the other one? In PowerShell. There are many, and it depends on the operating system. You can change that thing. So, for example, I'm going to share my screen. I'm going to quickly show you how to do that. So, where's my terminal? Here. So, I guess you can see my terminal here. No, I actually don't know if you're.
We can see the
Where's
settings.
I just lost my terminal. Wait, where is my terminal? Let me just. Yeah, I'm gonna just. I'm gonna. Yeah.
Here we go. So here you can see
yeah, okay.
window open.
Mm-hmm.
And here I'm actually just going to open a new one. So this is my terminal when I just open it up. And if I want to see which shell I'm using, I just say echo shell.
Yeah, exactly.
Voila.
Mm-hmm.
So I see now here bin bash. So if I actually go to this directory cd bin, I can. So cd is a command that does change directory, right? It goes from one folder to the other as if you're clicking on a folder in the Explorer or in the Finder. And here I can see all of my different shells, bash, CSH. So this is a bit of an older Mac that I'm using, but you can see TCSH, ZSH. So all of these flavors or recipes are living in this folder, right? And I can switch between them. So I can say TCSH, and now I've shifted H, and notice that my prompt has changed slightly. I don't have a $sign after the name, but now it's a %. Sorry, Carolina, please go ahead.
Yeah, and also on the top, you can see now it says bin CSH instead of bin bash. So
I have a bit of tunnel vision now, so I only look at the prompt. I don't even look at the name above.
Yeah.
So you were
and actually,
correct.
now that you have that open, if you click on terminal,
yes,
up in the kind of up there, and you type preferences, I believe, and then general.
Yeah.
Then there it says shells open with. So if you leave the default, every time you open your computer or you open your terminal, it will go to your full shell. The one that computer, the computer is built with a shell. So in this case, is whatever it's using. But in my case, for example, I prefer bash. So instead in my computer, it says shells opens with or open with, and it says commands, and the bin bash is activated. So every time I open terminal, it goes directly into bash. So that's another way you can change it so you know that you're always running bash.
Thank you.
Yeah.
So I'm going to switch back to my bash now. Yay. Also, there are different versions of bash. I think there are also different versions of TCSH, CSH, ZSH, etc. And the commands that you can use within either of these will be changing. Typically, there are slight changes, but there are some very handy tools in bash 4 and above, for example, like the command called read array, which can read a text file into a bash array just directly. You don't have to go through the headache of like parsing that line by line and so on. But I only found out about that recently, actually. But yeah, I hope that answers the question.
Yeah, something to have it a bit clear is like these shells are actually like a command line interpreter. So actually what they do is to translate to the machine what you're typing. It's just to try to have, it's like the medium that it's used to translate your input to the machine. That's the best way to interpret it, to give an interpretation to that. So it's actually, it depends if you're changing the medium or the media that you're using. It's like saying, instead of writing a letter, you're talking, or instead of, for example, I don't know, writing an email, then you decide to make a video. So that's the channel you're using for communicating with the machine is the shell. And it's very important because depending on the system that you're using for analyzing your imaging, you will probably need one, but most of them are Bash compatible. So probably all of them will work with Bash. So you don't need to worry about that.
Indeed, I think most of them are Bash compatible, but the ZSH, which is the one now, I think, coming by default in the new Macs, is, if I'm not mistaken, compatible with most Bash commands as well. And it even has some nice highlighting and so on. If there is one extra tool that you can install there that parses and highlights different parts of your input and even the output and so on in different colors, so that makes it a bit easier to grasp. But you can have a similar kind of highlighting going on for any shell script if you're using Visual Studio Code, for example, to write your scripts. You just need to go to the bottom. I can show you here one. Let me share my display again. Voila. So you can see here a window of a script I'm working on. And this is down here set to be a shell script. I just click here at the bottom. So if I start, let me just do a new one, and I'll write echo hello world, for example. Right? Now, at this moment, it doesn't really know what kind of script it is. But if I go here to batch, it thinks it's a batch script. So if I go here and I tell it, hey, this is shell, you see there's also PowerShell from Windows, which I do not use, but I mean, a lot of people do, because there's the Windows subsystem for Linux as well, which can be quite helpful if you only have a Windows system. And I click this, then it recognizes, okay, echo is my command, and hello world is a string within the double quotation marks that's going to be printed to the command line. Now, what's more is up here, this is your shebang line that tells the machine which flavor of shell you're using. And the -E tells it to quit on error, but yeah, we don't need this by default. Your typical shebang line will be looking like this. It's a hash key in the beginning, and then exclamation mark. And then this is simply the path to the bash file itself. I hope that helps. I'll stop sharing.
Are there any other questions, or everything was clear for everybody? Okay. Okay. Thank you very much, Ahmed, for being here.
It's a pleasure. Thank you for involving me, for arranging everything, and it's nice to meet you all, everybody. I wish you a lovely day, evening, afternoon. I don't know. Everybody's in different spots. I look forward to the next talk. I do look forward also to the FreeSurfer one, and I'm sure I have still a lot to learn about Bash and shell and image processing and so on. It's like a never-ending thing, right? You just keep learning. Just fun. And it keeps our brains healthy, right? That's the idea.
Okay, thank you.
I look forward to our next meeting.
Okay, thank you.
Bye. Thank you very much.
Bye.